Good morning, everyone. I am Yashiri, and this is my presentation on A-star-search algorithm for subject fundamentals of artificial intelligence. So today we are about to see the first thing is the main objective of this. This is for understanding the working principle of the A-star algorithm and to construct a graph with heuristic values and weighted edges. It is also to perform step-by-step A-star search to explain its real-world application. That is the main objective of this presentation. So, first of all, the introduction. The A-star search algorithm is an informed search algorithm. It is a type of informed search algorithm. It combines actual cost G and estimated cost H, and it uses both of them to choose the path with lowest f of n value. The f of n is calculated by g of n plus h of n. This is used for finding the optimal path between throughout the whole node, and then it balances exploration and goal directed search, so we can easily find the optimal path and shortest path. The custom graph with heuristics actually shows the example problem for that. These are the nodes A, B, C, D, E, F, and these are the connections between the A to B. There is a one value. And then the cost of the road between the A to B is 1, and the cost between A to C is 4. Totally, this edge calculates 7, and the heuristic value h of n, and from B to C there is a value of 2, and then B to D there is a value of 2, and so on. These are the edges, and these are the costs between them, and this is the heuristic value h of n. After that, we are here to see the algorithm principles. We are implementing the A-star algorithm principles on the above showed problem. So it maintains three key values. First of all, we calculate cost from start to end. From if we, for example, if we take this, we calculate the value between A to B, and the value of from start node to nth node B is 1. That is the GFN, and HFN is the estimated cost to goal. Estimated cost to goal. So goal between that F is the goal. The between A to F, the estimated goal is 7 plus 6 plus 2 plus 1. This is the f of n. F of n value, and it finally calculates f of n is equal to g of n plus h of n, and chooses the node with lowest f of n. Lowest f of n usually indicates the optimal path to expand next. It continues if we can't reach that between the two or three steps, it continues until the goal is reached or openness is empty. And after that, A-star search execution on graph. Where first of all, these are the steps, these are the nodes. It kind of has an um, these are the simplement. This is simplified format of the problem, and this is the g of n value. That means the cost from start node to nth node, and this is the h of n heuristic value. This is the total value between these. This is the total value from calculating the optimal path f of n equals g of n plus h of n, and this is the path from A to B, B to C, B to C to E, then C to F. C to E to F. The optimal path is finally found after 5 steps: A to B to C to E to F. The total cost is 9. Here is the heuristic value. Therefore, we found the optimal path. The optimal T is basically because A star is an optimal, it is optimal if heuristics are admissible. Admissible means it never overestimates true cost, so we can easily find the shortest path. And it also ensures f of n values guide search accurately. Therefore, A star is both, we can conclude that it is both complete and optimal, and can be used very easily to find the optimal path. So the application is main application is we all know GPS navigation. It finds the shortest driving path whenever whatever the purpose of the driving is. Also, it is helps in robotics, obstacle-free motion planning, and then video games, NPC pathfinding, and AI movement. In logistics, we use it for route optimization. Warehouses, for example, Amazon or online delivery companies use this to find the shortest path to be delivered to the customer. In those areas, A-star is widely used. Therefore, A-star uses f of n is equal to g of n plus f of n. This is the main algorithm that is used in this A-star search algorithm for informed search. Also, it works on weighted graph. For example, there is a lot of graphs that can be in which BFS, DFS are not cannot be performed. In those categories, A-star can be performed with heuristics. Also, it has admissible heuristics that ensures optimality. So, it can be many useful in many ways. Also, it is widely used in navigation and AI applications, as we have saw in a real life application. That concludes it. We all know that SR is an efficient, optimal, practical search algorithm, and it encourages students to experiment with different graphs and heuristics. So that concludes my presentation, and thank you. That concludes my session of A star search algorithm. Thank you.